Okay, let's get right into it. Application on the gradient. So in the past videos I posted, it's basic theory on analytical geometry, part 1, application on distance, part 2, application of midpoint, and the last one is application on gradient. So please watch all of those videos, and then I hope they're gonna help you so much. So the gradient, already I mentioned some cool points, but let's just recap them again. So that's the formula for the gradient, and we need to know this following. So if lines are parallel, they will have the same what? Gradient. So literally the gradient will be the same. So if they're telling you that it's parallel, it means the gradient are the same. If they say the gradient are the same, then they're saying it's parallel. So it's an this is an if then statement, whatever. You can go to the front and come back. Yes. And then number 2, perpendicular. Perpendicular is the sign, meaning the gradient of the two, when you multiply them together, you must get -1. So there you go there. I hope you see it. And the last part is collinear. The gradients are the same, so also same gradient. I'm just going to write that, and then we're going to prove it. So in grade 11, it's very much important. They assume that you know these laws, these 3 things. So they just go straight into applying it on geometry, on Euclidean geometry. So you should know these things. So let's go. Let's start with the first question. So parallel lines, blah 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 blah, you know that. So let's do question 1. Okay, I'll call it example 1. So if you are given the points A as -1 and 5, you are given B as -2 and 3, you are given C as 9 and 10, and you're given D as 5 and 2, the question will say, show that AB is parallel to CD. Very important. This is the symbol for parallel lines. And then how we're going to use the parallel lines, we're going to use the gradient formula. If we can find the gradient of the two and then actually show that they are equal, then we have proven that the lines are parallel, just like that. So right on top of this, I'm going to say x1, y1, x2, y2. So this is for AB, and then for BC is going to be x1, y1 again, and x2, y2. Then we just substitute. Perfect. Let's go. The formula is y2 minus y1 over x2 minus x1. Then we start your substitution. So we start with the y values. Remember the change in the y value. So 3 minus 5 over -2 minus into minus. Can you see? The formula has a negative, and this question is coming with its own negative. So we're going to have on top there 3 minus 5, it's -2. Here -2 is going to be -2 plus 1, which becomes -2 over -1, which becomes +2. So this is the gradient, small letter m, the gradient of AB. A negative divided by a negative will give you a positive. Then let's do the gradient of CD. Formula is the same. Then we substitute 2 minus 10 over 5 minus 9. 2 minus that one is a -8. This one minus that one is a -4. 4 goes into 8 how many times? 2 times a negative and a negative gives you a positive. So we can actually see that the gradient of AB is the same as the gradient of CD. Therefore, these two lines are parallel. So it's a line. This is AB, and then is CD. So we didn't have this. We can put it now because these two lines are parallel. So that's what you're going to do if they ask you a question like that. Wonderful. Let's go to question 2. Example number 2. Yes, that's my ruler there. Collinear. How do you show that lines are collinear? Collinear. We said how to find collinear are lines that are on the same points that are on the same line. Let's say we've got a point there, A, B, C. So if the lines are on the same lines, their gradients must be the same. So the gradient between AB must be the same as the gradient between BC, must be the same as the gradient between AC. Whew. It's quite a lot of work, but we have to do it. We're gonna do it. So the question says, show that the points A, B, C are collinear. So it's very important. If they give you that lines are collinear, if they give you this statement, it means the gradient is the same. You can actually use it to find maybe straight line equation. We're gonna do more questions when we're doing past papers, so be on the lookout. Keep checking the channel, and then you will be fine. You will be prepared. Points are, so they give you the points A, B, C. This one is 2 and minus 2. This is B, 1 and 1. I know it's a bit boring, but you have to practice and more practice and more practice, so that you are going to ace the test. So here I'm going to find the gradient between AB, the gradient between BC, the gradient between AC. So I'm just writing them out like that, then I substitute. So in this case, you choose x1, y1, x2, y2. It does not matter at this point. So it's gonna be what? 1 minus into minus. So what you can do is actually pause the video and do it yourself, and then actually see that you get the same answer. Alright. Okay, so this is 2. 1 plus 2 is 3. 3 over minus 1, so the answer is a negative 3. So we have to get a negative 3 for all of this if my answer is correct here. So let's see. So now I'm doing BC. There's 2, x1, y1, x2, y2. So it's going to be 7 minus 1 over minus 1 minus 1. So 7 minus 1 is 6. This becomes minus 2. 2 goes into 6 how many times? 3 times. A positive and negative becomes a negative. Wonderful. Now we have to do the last one. I hope we get it right. So this one and that one. x1, y1, x2, y2. So 7 minus into minus. So it's going to be a plus there. I can just go ahead and do it right. I am not losing anyone. Minus 1, minus 2. 7 plus that one, it becomes a 9. Minus 1, minus 2 becomes a minus 3. 3 goes into 9 3 times. A positive and a negative becomes a negative. So, okay. So the gradient of these 3 points are the same, so they are the same, they have the same gradient. So in this case, we are not talking about distance. Obviously the distance between AC will never be the same as the distance between AB, but we are dealing with gradient. So gradient and distance are totally different topics. Let's do the last topic, the last part, when we're dealing with what? Perpendicular. So perpendicular lines, Dracula. Perpendicular lines, they intersect at 90 degrees. They form a right angle. So when you see a line like that, here it's a 90 degrees. We call it the right angle. So what are perpendicular lines? Are lines that meet at the 90 degree angle. They are meeting at the 90 degree angle. And then, very important, to prove that two lines are perpendicular, let me not waste time. Their product must add up to minus 1. So let's just do a question quickly. No wasting of time. Given the points A, it's 3 and minus 3. Given the point B is 6 and minus 7, given the point 5, it's minus C is minus 5 and 0, and D is minus 1 and 3. They say that show that AB, so I'm going to go ahead and put that sign there so that you're comfortable with it. AB is perpendicular to CD. So how are we going to prove that? We're going to find the gradient of AB and find the gradient of CD, multiply them together, and then if they are perpendicular, they must add up to minus 1. Yes, so the gradient between AB will be y2 minus y1 over x2 minus x1. Okay, so it's minus 7 negative into negative x2, it's 6 minus 3, which is minus 7 plus 3, which is 3. This becomes minus 4 over 3. We leave it right there because of there's no number that can go into 4 and 3 without a remainder, obviously, except 1. And then CD. Okay, we do this 2. 3 minus 0 over minus 1 minus into minus. So it's going to be 3 minus 1 plus 5, which is 3 over 4. All right. Now, if AB is parallel to CD, then I'm going to write like fancy stuff right there. Show your examiner that you know what you're talking about. Okay, substitute this. What is the gradient of AB? It's minus 4 over 3 times, this is what? 3 over 4, multiply them together and see. I have a calculator right here. I can do it without a calculator, but you just have to prove. The other one is 3 over 4. Can you see? Minus 1. It's actually minus 1. This is minus 1. So the left hand side is also right hand side. So you can actually prove this and this goes in 1, this goes into 1. 12 divided by 12 is 1, minus 1 because of a negative divided by the positive. Blah, 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 blah. Sharp. So we have proven, therefore AB is parallel to CD. I just want to say something quickly in less than 80 seconds. Look at this. There is some relationship between this, and then next year, okay, why am I saying next year? Grade 11 is very important because this is grade 10 work, obviously. Okay, it's very important that you know the relationship between perpendicular lines. Look at this. This one is 4 over 3. This one became 3 over 4. Can you see that they are swapping? So if the gradient of this one is 4 over 3, this one is going to be 3 over 4. And they have opposite signs. If this one is a negative, this one will be a positive. Do you see it? So if they tell you that, let me just give a random example. If they give you like saying, they give you the gradient of EF and they say EF is 3 over 9. Okay, 3 over 5. 3 over 5, okay. And they tell you that EF is perpendicular to AB. This statement alone, they have given you the gradient of AB automatically because you know that is going to be the reciprocal of this. Yes, I said the word. The reciprocal of that fraction with an opposite sign. So therefore, if they are perpendicular, meaning the gradient of AB will be 5 over 3, just like that. Do you see it? If they said EF was 2, let's do this one. What will be the reciprocal of 2? We know that every whole number be written as a fraction over 1. So meaning the reciprocal of that will be 1 over 2. If this is a positive, this becomes a negative. So can you see that we can find relationships of gradients when we know this? If they tell you that the lines are perpendicular, you can do this. If they tell you that the lines are parallel, you can do that. You can say if they are parallel, meaning the same gradient of this one will be the same gradient for that one. Thank you very much. Like the video, comment, share to your friends and loved ones. I'll see you on the next topic. Thank you.